Thanks for watching the screencast. The objective of this screencast is learners will be able to use the product, quotient, and power properties of logarithms to rewrite logarithmic expressions. So there are three logarithm properties that you need to know and use for this objective, and they are right here on your screen. It says for all positive numbers m and n, and b where b is not 1. And the reason b can't be 1 is that it's the base of a logarithm, just like we discussed in Learning Target 26. We have the product property of logarithms that says that log base b of a product of m times n is the same as log base b of m plus log base b of n. Here's just one example of the implications of that. Log base 3 of 20, which could be written as a product of 4 and 5, is absolutely the same as log base 3 of 4 plus log base 3 of 5. If I can write the input to a log as a product, I can write that same log as a sum of two logs with the same base, using each of those factors as the input for the logs given. We also have a quotient property, a property that says that log base b of m divided by n is a log base b of m minus log base b of m. And then we've got the power property, which says that log base b of n to the a power is the same as a times log base b of n. Those three properties are what we're going to use to rewrite logarithmic expressions. So here are a couple of examples that say to expand the expression. You know, to expand something is to make it as big as possible. So my goal to expand this expression is to take an expression that involves one log term and write it with as many logarithmic terms as I can. So I want to rewrite log base 4 of 7x cubed divided by y. What I see here is that I have a quotient of two things, which means I could rewrite that as a subtraction problem. Log base 4 of 7x cubed minus log base 4 of y. That's using that quotient property. Now what I see here, once I've done that, is that I now have a logarithm that has an input that can be written as a product. So 7 times x cubed, I could rewrite just this term as a product. I could say that's log base 4 of 7 plus log base 4 of x cubed. And then I want to go back and don't lose my minus log base 4 of y. And I think I see even one more thing that I can do, because I see that this log term here, log base 4 of x cubed, has a power, and I can use that power property of logs to rewrite that term as 3 times log base 4 of x. So the most expanded version of this log here, log base 4 of 7x cubed divided by y, that I could write is log base 4 of 7 plus 3 log base 4 of x minus log base 4 of y. So that right there is your goal. Expand the expression. Here's another example. Here's log of, that's log base 10 of 10a cubed b to the negative second. Now what I see here is one big product that involves three factors. And you know, the property on the previous screen showed you a property that works for two factors, but that same property applies to three factors. So all I really need to do to begin this is to say, hey, I can write this as the sum of 3 logs base 10. That's log base 10 of 10 plus log base 10 of a cubed plus log base 10 of b to the negative second. I see not one but two terms that have powers associated with the inputs to the logs, so I can rewrite those terms using that power property of logs. I could write the second term as 3 times log base 10 of a. I could write this, negative 2, I could write that as minus 2 times log base 10 of b. And I've got log base 10 of 10. And I hope there's a thought you're having right now. You could actually simplify that a little bit more. Because log base 10 of 10 is asking what power of 10 gives you 10. That's just 1. You see that? Log base 10 of 10 is just 1. So really the best kind of expanded, simplified answer here would be something like 1 plus 3 log base 10 of a minus 2 log base 10 of b. Now, we also want to work on some problems that ask you to condense an expression. To condense something means to make it as small as possible. If you open a can of a popular brand of soups, you'll see on the label it says the soup is condensed. And the reason why that's true is to make it soup, you need to add an appropriate amount of water. They've made it as small as possible to make the packaging work out. Condense means to make as small as possible. That means I want to take the expression that has several log terms in it, and I want to try to write it as one log term. So what I see here is that I see kind of a process where I can work the same problem we worked on the last screen backwards. Log base 2 of x plus 3 log base 2 of y minus log base 2 of z. I see that I could write this 3 log base 2 of y. I could write that term as log base 2 of y cubed. What I see now is I see a sum of 2 logs that I could write as a product with one input, one term, log base 2. It would be x times y cubed. X, y cubed is the input. Then I've got my minus log base 2 of z. And what I see left now is one log term, 2 log terms separated by a minus sign. That makes me think I could write that as one term where I divide x times y cubed all over z. And there is our condensed expression. Here's another example. Log base pi of 8 minus log base pi of a plus 2 minus 4 log base pi of b. I thought it might be helpful if I saw 2 negative terms here. It might be helpful to almost factor that negative out first. So log base pi of 8 minus, let me factor out that negative sign and make that a plus sign. Log base pi of a plus 2 plus 4 log base pi of b. Well, I see a multiplication that can be written as a power of the input. So let's do that move. We've got log base pi of 8 minus log base pi of a plus 2 plus, this would be log base pi of b to the 4th. I see a product, or I see a sum of 2 terms that can be written as a product. So I've got log base pi of 8 minus, the sum of these 2 terms should be written as 1 log base pi of the product of those 2 inputs. So I'll do something like a plus 2 times b to the 4th. And finally, I see 2 logs separated by a minus sign. Let me write the answer of the simplified expression with 1 log, and let me put the 8 on top as the input, and on bottom I'll put a plus 2 times b to the 4th. And there we have it. Okay, I've got a couple for you to try now. One for you to expand, and one for you to condense. You should hit pause, see if you can work them out, and then when you've got them worked, get ready to give yourself some feedback. On A, you were asked to expand this expression. You're going to try and write it in as many log terms as possible. I see this ultimately as a product of 3 things. Log base 5 of 25 times c squared times the square root of d. So let me write it first as the sum of 3 logs. Log base 5 of 25 plus log base 5 of c squared plus log base 5 of the square root of d. So I've got it written as a sum of 3 logs. I see that I could write, with a power of 2 here, I could rewrite this term. Can I rewrite this also? Yeah, what power of d is the square root of d? It's the 1/2 power. So since square root of d is d to the 1/2 power, I can write this term as 1/2 log base 5 of d. And that's really where I'd like you to get on that. This term here can be written as 2 times log base 5 of c. Is there a way to rewrite this term also? Yes, that's just 2. What power of 5 gives you 25? It's 2. There's our best answer on A. On B, you were asked to go the other way, condense the expression. Here I see 2 coefficients that can be rewritten as powers of the inputs. So we've got log base 3 of m squared plus log base 3 of, what is n to the 1/3 power? It's the cube root of m. Yeah. Sorry, not m, n. Magic. Ta-da, fixed it. N, cube root of n, minus log base 3 of p. And then from there I see 2 terms that are added together. Let's write that as 1 log with a product of the inputs. Log base 3 of, let's write m squared times the cube root of n minus log base 3 of p. And finally, I've got a difference of 2 logs, so we're going to write that as 1 log with this on top and this on bottom as the input. M squared times the cube root of n all over p. And we've got it. Thanks for watching.